Okay, let's go ahead and get started using the contents of this student application kit to go ahead and install a strain gauge. Now the first step, you can follow along with this video, you can follow along with the checklist or the instruction bulletins included with the kit. First step is going to be to degrease the surface of the aluminum. And to do that, we're going to use the GC6 alcohol, and we're going to use a gauze sponge. So here, I'm just going to saturate the gauze sponge with some alcohol. We're going to wipe down both surfaces of the beam. We want to do the whole top surface because later we don't want to drag any contaminants back into the gauge area. You can see that there are some materials present here. The edges. Maybe go over it with clean gauze. If you do all these steps very thoroughly and carefully, as I'm showing you here, your chances of bonding a gauge successfully are extremely high. Okay. Now, the next step in preparing our surface will be to abrade, and we're going to do this with the 320 grit silicon carbide paper. And this is going to be a wet abrasive step. And what I'm going to use as the wetting agent is going to be the red tip bottle. This is the Imprep Conditioner A. This is a mildly acidic solution that will remove oxides from the surface of many metals, aluminum included. In here, I'm going to abrade close to, I've got a couple of marks that'll be difficult to show on the camera. I'm going to abrade pretty much the whole top of the beam. And I'm not going to go excessive on it. I'm going to just go back and forth a few times. We're not trying to remove material here. We are trying to roughen the surface and clean the surface so that we get a good bond. Now you notice I'm using a stack of paper here. This is convenient because as the paper becomes dirty, you can just move it and then you got a clean sheet to work on. So after the abrasive step with the 320 grit, I'd like to show you the wiping technique that we recommend. My gauge area is going to be about here. So what you want to do is wipe in one direction only through the gauge area. I'm going to put the gauze pad down right here. I'm going to wipe all the way through the gauge area, not going back and forth, all the way off the end of the beam. Gauge area is here. I'm going to start here and wipe the other way. Now, why did I do that? If you wipe back and forth, you're just going to redeposit contaminants on the surface that you're trying to remove. If you wipe in one direction, you're removing the conditioner A plus all the grains and contaminants that you've abraded off the surface. And also, never let that conditioner A dry on the surface after you do something like this. You need to absorb it. If it air dries, it's just going to recondense contaminants onto the surface. Okay, now once we have our surface rough abraded with the 320 grit, I'm now going to go back over it and do a finish abrasive step with the 400 grit silicon carbide paper. And it's the same process as before, so I'll just demonstrate, and we're going to use the same steps that we just did. Okay, so now I have the correct surface roughness for aluminum. I will be able to get a very good bond that's going to transfer strain without loss. Now, I'm going to put some alignment marks on this aluminum. I'm going to use the 4H drafting pencil that's included with the kit. I'm just going to put some marks on the top here. I have some scratch marks on the edge of the beam that's going to mark where a potential gauge location can be. So transfer that so I can see it. I'm going to go ahead and use the glass plate here as a straight edge. And I'm going to go across there with this pencil a few times. Now, if you read our tech note on strain gauge surface preparation, it goes into a lot of detail on The reason I'm doing some of these things now on aluminum, I'll tell you why we use a 4H pencil, is because we want to produce a burnish. We don't want to scratch the surface. We don't want to use a tool or something that's going to dig into the aluminum. On the sanded surface that we just created with the silicon carbide paper, this 4H pencil will flatten some of those peaks, so that when I remove the pencil lead later, it's going to leave behind an optical line. It's called a burnish, but there's no surface deformation or strain concentrations created. And that's very important when we're trying to measure strain. Okay, so now we need to use our cotton tipped applicator. Again, I'm going to use the red tip bottle. This is the conditioner A, still the acidic conditioner. And first I'm going to scrub that lead off. Okay, once I get most of that off, then I'm going to scrub in the direction that I sanded. And that will clean out the grooves where the surface has been abraded. And again, I'm always working an area larger than I need for the gauge. Same drying technique as before. I'm going to start outside the gauge area, go off one end, start outside the gauge area here, go the other way. Now the final step in a correct surface preparation is to neutralize the surface. We've been using an acidic conditioner. It's a mildly acidic conditioner. The pH is not all that low. So we're going to use a mild alkaline substance here called neutralizer 5A. And this is going to raise the surface pH to just where we want it, close to neutral, which would be about ideal for instant curing cyanoacrylate adhesive like our M-Bond 200. Again, I'm going to work it into the grooves with the cotton tipped applicator. I'm going to dry the surface. Same wiping technique. Okay, this surface is now precision cleaned. I believe you could probably see the burnish mark that's left behind. That's not pencil lead. That's an optical burnish left behind on the soft aluminum by the 4H pencil. Okay, so I'm going to set that aside for a second. Now we're going to work with the strain gauge, and this is where you use the glass plate. Now, I've been handling this, so it's going to have some fingerprints on it. I'm going to go ahead and put a few drops of the neutralizer. This is the blue tip bottle. And we're going to clean that glass off a little bit before we lay our strain gauge on it. This is the strain gauge that comes, one of the 5 that comes with the kit. And it's a C2A 13 250 LW 350 ohm. This has a 1/4 inch gauge length and it's pre-cabled. It's got a 10-foot length of cable on it. So once we've on the strain gauge, it's ready to connect to the instrument. Now, hang on to this card because this has our engineering data on it, information that you'll need to make an accurate strain measurement, such as the gauge factor, transverse sensitivity, resistance, etc. Okay, these pre-cable gauges, you should probably leave the cable bundled until you're finished with the installation. This will hold it all in place. You can just slide this out of the sleeve and lay the strain gauge on the glass. Now, the way we're going to handle the gauge for installation is with our tape. What's included with the kit is called PCT2M tape, and what makes this tape special is that we've tested it. We've worked with it thoroughly. We know that there's nothing about this tape that's going to contaminate the surface, that's going to be incompatible with the adhesive or any of the materials that we use during the installation. So we've tested it for you, and we know it's going to work good. I'm going to tear off the first couple of inches, which might have a bit of dust on it. Then pull off a 2 or 3 inch length here. And a lot of different ways people prefer to lay the tape across the gauge on a pre-cable gauge. Now, my personal preference on a beam like this and the orientation of the gauge that I have here is to go across the gauge. And so I'm going to lay this tape across the gauge. There's no precision alignment being done here yet. We're just going to use this to pick the gauge up off the surface. So there it's tacked down to the glass surface, and now I can lift it at a very shallow angle. And once I get it past the edge of the gauge, I can lift the other side. And now I have the means to handle the gauge while I position it precisely on my alignment mark. So I'm going to lay the gauge close to position. Again, these wires, you have to handle them as you're working with the tape. And once I've got it close to position, I can use this tape and the alignment marks that are included with the strain gauge to accurately position. Actually, I'm going to turn this around. I think I'd like to on the gauge so that my wires are oriented this direction. You can look through the tape here, visually see the alignment marks, and position your gauge. Now it's important when you lay this gauge down, you don't want a lot of tension on the tape. That's going to stretch a pretty large offset into the strain gauge, and it's going to get bonded in place. So when I actually lay the tape down, I'm going to have very little tension on it. I'm going to lay it down. It's going to hold it in position at the alignment marks. And my wires can just sit here for the moment. Okay, now we're ready to bond the strain gauge. The tape will hold it accurately in position, so I can lift one side of this tape, get it just past the strain gauge, lay it over, and then pull it back slightly. That's going to expose the back surface of the gauge. By the way, I should have mentioned it earlier, but this gauge is positioned so that the dull colored side is downward. There's a dull side and a shiny side on these gauges, and the dull side opposite the wires is the side that you want to bond. So that side was down, now it's flipped up, ready for the application of the adhesive. This is the catalyst C that's included with the kit. And like any catalyst, the chemical purpose of it is to speed up a chemical reaction. So we're going to brush this on the back of the gauge only, not on the surface of the aluminum. And you don't use this wet. I've seen this done incorrectly before, so I want to be sure and point it out here. The catalyst is allowed to dry. The chemical substance that is the catalyst is suspended in a liquid. So we let that liquid alcohol flash off and evaporate, leaving the catalyst on the surface. So you got to allow a minute or two here for drying time before you put the adhesive on. Okay, so our catalyst C has dried for 2 minutes. We're now ready to apply the Mbond 200 adhesive. Little 2-gram bottle here, which is convenient. These are nice because I can open this bottle and use it. Meanwhile, the other 4 that are in the kit remain unopened and will remain fresh for a longer period of time, maximizing their shelf life. So I'm just going to clip the top of this off here. The little thing I like to do, a little personal preference, but I like to squeeze the first drop out and just throw it away, just in case there was any adhesive sitting in the tube at the top on the straw part. Okay, now the way you apply this, you want to pull the gauge back about 1/4 of an inch from where it's going to land, because I want to put the adhesive down and allow room for this to spread out as I lay the tape down. So I've got about 1/8 of an inch of space here. I'm going to put a single drop of adhesive right on the edge of the tape interface. And I'm going to take one of these gauze pads. And I'm going to hold the tape over while I use this gauze pad to swipe the tape down. That's going to spread the adhesive beneath the strain gauge. And then I'm going to immediately apply thumb pressure. I'm going to hold this for at least 1 minute. Okay, 2 minutes has elapsed, and I'm now ready to remove my thumb. If your thumb sticks a little bit, just twist it and pull it off. Should be fine. And now I'm going to remove this handling tape, and this will complete the bonding of the strain gauge. Now, to remove this, I'm going to pull it at a very steep angle, 180 degrees back on itself. I'm going to kind of slide it back and off the wires. Now, right next to the strain gauge, the wires are bonded. And that's a good thing. That'll help you remove the tape easier. So those wires are actually stuck down right there. They're still a little bit loose right here. And the next thing I would do, I think we'll go and apply our protective coating. I'm going to unwrap these wires, and I'm going to use the twist tie that's on it to anchor it to the beam. This will just help me hold it in place and not worry about it moving around until I get the coating on it and get things permanently attached. Okay, now we're ready to do the final step, and that's going to be to apply a protective coating. Here we're going to use the M-Coat A. It's included with the student application kit. Now the purpose of this coating is to isolate the sensitive resistance element from changes in humidity to give it a little bit of mechanical protection. It will also help to seal these wires down to the surface and make the installation more rugged. So a couple of things that a coating does for you. It gives you some environment protection to help preserve the sensitive resistance changes in the strain gauge. It also makes it durable. Okay, at this point, this completes the installation of a C2A strain gauge using all the materials that are included with the student application kit. Now, what we'll do next is continue on with the use of the kit, and we will connect this to our student DAC and make a strain measurement. Okay, now that our strain gauge is bonded, we're ready to use the instrument that's contained in the student application kit. This is Micromeasurement's student DAC, student data acquisition. And this is actually a very handy little instrument. It has bridge completion built in. You can do, in this case, 350. We make a version for 350 ohm gauges, quarter bridge. We make a version for 120 and one for 1000. In addition to in the case of this one, a 350 ohm quarter bridge, you can also do any half bridge or full bridge, and there's nothing else needed. All the bridge completion is built in. Now, to connect it, also included in your student application kit, is what we call an RJ45 screw terminal adapter, RJ45 STA. Now, you can crimp a connector, a standard RJ45 10-pin connector, onto this ribbon cable, but this makes it a little more convenient because you can just insert the wires and use the screw terminal here to make a reusable connection. So we'll go ahead and connect our strain gauge. I've already got it connected correctly on the screw terminal adapter. And we're going to plug it into the port on the student DAC, and I'll go ahead and connect this to our PC. Okay, now everything I've showed you there is included with the kit. This is a little cantilever fixture. This is not included with the kit. It's something we use for demonstrations here. But I've got our beam attached. Now we'll go ahead and bring the software up. This software is downloadable from the Micromeasurements website. So when you purchase the student DAC or the student application kit, the software is included with the kit. It's on a jump drive, but you can also go and download newer versions on our website. I'll go ahead and make this full screen. This is a very simple little application. You can get very easily better than a 1% accurate strain measure with the setup that we have here. Now, I kept my data sheet. What I need to know at this point is the gauge factor. This is 2.120 for this strain gauge, plus or minus 0.5%. Now, gauge factor is your calibration for measuring strain. It is simply the ratio of resistance change to strain. It's the slope of a curve, or actually a line, that would be resistance versus strain. So I'm just going to type this into the blank here for gauge factor in the software. 2.120. And that's all I need to do. I'm now scaled to measure in units of microstrain. I'm going to zero the instrument, and I'll go ahead and start scanning. So you can see our plot here of strain. Now, as I flex the beam, you can see the strain and tension or compression. Now, it's a little bit hard to read. We can get a little bit better resolution if I change the scale here, which is very easy to do. I'll just make the top scale 500. I'll make the bottom scale negative 500. Now we can get a little more resolution. You can see what this is capable of. Now, one of a very common question is, once you've gone through the process to install a strain gauge on some test object, how do you know if it's working correctly? And it's a very simple answer, and you can illustrate it here. It's called zero return. And this is 2024 T4 heat treat aluminum, so it's very spring-like material. And if I apply a strain to this and then let go, it should snap back to 0 microstrain very reliably. A strain gauge that's not installed correctly will not behave in that manner. It will not exhibit a good zero return. So the fact that we are seeing a very good zero return here is our best indication that the gauge is functioning correctly and that our strain measurements will be accurate. Now, these C2A series gauges are pre-wired with a 3-wire connection, 10 foot of cable. Normally, we might have to correct for a lead wire resistance on that. But 10 feet of a 26 gauge cable is pretty negligible, and the 3-wire connection will give us temperature stability. So if this cable were to change temperature, we would not have any erroneous output due to temperature from the cable. Okay, so there in one kit, this student application kit has everything that you need. From the strain gauge to the bonding materials to the actual instrument to make a measurement.